Hi everyone, in this video we will see how we can implement object tracking using DeepSORT in YOLO V8. We will be tracking ID as well as trails. We will create an application in this video as well, in which we will implement the number of vehicles entering and leaving a highway road. So as you have seen the demo at the start of the video, so let's move forward. In the first step, you can see as this is my GitHub repo, which I have created for YOLO V8 deep sort tracking. So first of all, I will clone this GitHub repo into my IDE. I will be using PyCharm for the implementation of this project. So as I don't have a GPU, so you can also implement it on CPU. I will be showing demo on CPU. So if you have a GPU, you will follow the same steps. So no step will be changed. You will follow each of the same step if you have a GPU-based system. If you don't have a GPU-based system, then I also don't have a GPU-based system, so I will be following the same steps. So here is the Colab file link as well. You can implement in Google Colab as well. It's a single-click solution. So I will be showing you the implementation on PyCharm ID. In this video, I will be explaining the complete code as well. So please watch the complete video, and hopefully at the end of the video, your very much concepts will be clear. So let's start the implementation. So first of all, I will create a Python. I will open PyCharm. So this is my GitHub repo I have just published 10 hours back. So let's look into more details. So just opening the PyCharm. Okay, in the meanwhile, as the PyCharm is loading, let's me create a folder here. So we can name it YOLOv8 DeepSORT tracking tutorial. Okay, that's nice. Sounds good. Okay, so first of all, I will go to files. This is previously open project. I was just checking few things. Go to new section. Okay, no, sorry. I'll go to open. And then what file I have created? Yeah, this is the file. Just in this file. Trust project. Click on trust project. This window, yes. So let's move forward. So first of all, nothing to worry about. Just go to the terminal. Just open the terminal. I am using PyCharm. You can use VS Code or any other IDE which you like to work on. So no worries if you are working on any other IDE. So first of all, we need to clone the GitHub repository. So here, all the steps are mentioned as well. So let's just follow the steps I have mentioned in the GitHub repository. So first of all, the step is to clone the repository. I will be explaining the code as well. Don't worry. So just go here and just control V and press enter. Nothing to worry about. So it might take 2 to 3 minutes. So let's wait. Okay. So now we have cloned the GitHub repository. Okay. So in the next step, we need to go to our clone folder. So just copy this and just go to the clone folder. So now we are in the clone folder. Now we need to install the requirements as well as install Ultralytics. So install requirements, right click install minus requirements dot txt. Let's install all the requirements. Here we have this requirements file. You can see over here. Now install Ultralytics as well. Like you can see that the next step after requirements is to install Ultralytics. Install Ultralytics. So it might take a few minutes. So as I have already done many working on it, so it's appearing like requirements already satisfied. Like these packages are all already installed in my Python 3 library. So if not installed on your side, it might take few minutes. So don't worry about it. So now setting the directory. So okay, so now we are setting the directory as YOLO V8 detect. So let me show you what it is. So this is YOLO. Let us close this first. And this is V8 folder, and then we go to the detect folder. So first of all, let's look at the tracking script. So this is the tracking.py file, which I am redirecting my directory to. So for example, currently my directory is set as configure Python. settings, just setting this. Just give me a second. Let me fix. So just click on OK now. I will just configure. So this is a tracking.py file over here. I am just redirecting to this folder, like detect folder, which contains a tracking.py file. So currently I am over here, YOLOv8 DeepSORT, the main folder. So to redirect over here, I will go to cd YOLO dash detect dash v8. Sorry, don't, this is the v8 and detect is the subfolder of the v8 detect, and just click on enter. Okay, so now we are here in the detect folder and this is a tracking.py file. Okay, so now we have redirected to this folder. So the next step is to download these DeepSORT files from this Google Drive and place into the YOLOv8 folder. So basically the DeepSORT sort file size are very large. So we cannot upload on GitHub of a file above like 25 MB. So these are very these files are size have above 100 MB. So we would prefer so therefore I have uploaded these files on the Google Drive. So you can download these files from Google Drive from here and just place them into the folder like I will mention. So it might take minutes. Let us go. Let us wait in that. Okay, that's weird. So okay, so finally download it. Okay. It might take few minutes. So now just go to this folder. This folder is present over here. Just click on extract files. Okay, this is the folder. These are the files. So I will just copy it and just go to YOLO. See, this is the folder, and just I will paste over here. This is my folder, and I will just paste these files over here. Okay. So please follow the step which I have explained here. Don't skip any step. Okay. So if I see now, these are DeepSORT PyTorch files appearing over here. Why we are downloading DeepSORT PyTorch? Because we are implementing a tracking using DeepSORT, tracking ID as well as trails using DeepSORT. So please remember this point. Okay, so let's go over here. And just for testing, I will download the sample video from this drive link. So directly download the sample video from here. Okay, now I've downloaded the sample video as here. So now just to run this script. So it as I'm testing on CPU, so it might take time to run the script. It will take time to run the script. So in the meanwhile, the script will be running. I will explain you the complete script. So what's going on at the back end. Okay, so it's working. So in the meanwhile, as you can see that the script is being running. So let's go to the code. So as you can see, the script is being running. So it might take some time, like you can see that it's working. So let's wait till the implementation gets complete, and then we will see the output video. So in the meanwhile, let me explain you the complete code. So first of all, this is the tracking.py script. For example, this from here, basically we have imported the base predictor from YOLO, Ultralexis YOLO engine, as well as I'm just importing the annotator, colors, and save one box. Although you're not using this save one box over here. So, but I'm importing from the prompting library. Here I have just imported CV2, so in computer vision library. From here, these are the libraries which I have imported from the DeepSORT files. these two libraries. And from collections, I have imported DQ. So what we are doing is in DQ is basically DQ is so DQ is basically you can say that. Let me write over here. DQ is basically a double-ended queue icon. So why we use DQ? Basically, we prefer DQ over list when we need to perform insertion or pop-up operations at the same time. So DQ is basically a double-ended queue. We prefer DQ over list when we need to perform insertion or pop-up operation over same time. So here we are basically where we are using here we why we are using DQ is basically uh, when we find the bottom center of the bounding box, we basically after finding the bottom center of the bounding box, like for example here we have a car or a truck. After finding the bottom center of the bounding box, we append basically them to in the form of DQ. Like for example, the bottom center value is 2.8. I will append this value in the DQ. So basically, we can define the maximum length of a DQ as 64 or 32. So these value will be appended into the DQ. For example, now the car exists from the current frame. So we need to remove this value from the DQ. So, okay. So basically, when the cars come into the frame, the value of the bottom center edge of the bounding box is appended into the DQ. As the car disappears from the frame, we need to remove the value from the DQ of the center value from bottom center of the bounding box value from the DQ. So here we are forming insertion and pop-up operation at the same time. So therefore we prefer DQ over a list. Plus we can have defined the maximum length of DQ as 64. So it will not accept values above 64. So as the values get 64, it will not accept the further values. Okay, so this is here we are using the DQ as well. So further details will be given. So here we are defining the color palette. Here we are defining DQ, and here we are just initializing DeepSORT as none. And here this is basically the code. Here we have initialized all the DeepSORT because my tech tracker is DeepSORT. In some cases, you can use sort algorithm as your tracker, ByteTrack as your tracker as well. But here I'm preferring a DeepSORT as my tracker. Okay, so this is all the code where we basically calculate the relative bonding losses for absolute pixel values, and this the same quality code is fair as well. So this is basically we compute color for labels. For example, if the label is car, so this specific color will appear for the car. So basically, it's a purple color, and if we have a bus, it's around pink, light pink color, and we have different color for the motorbike. So if the label is not from these, so it will randomly select color from the palette. So here we have defining. Now basically here what we are doing is we are creating a using draw dash border. Basically we are creating a good UI. So let me tell you a bit more in it. So look, you can see that this is the car. This is the UI. Like you can see that this is appearing in the rectangular form. Like you can see that this is in a rectangular form, not in the square. So if I want to create this into the square form, I can simply use rectangle. But you can see that the UI is in the form of like stylish form. Like you can, it's not in the rounded rectangle form. Like you can see that. This is in the form of rounded rectangles. So I am just creating this UI through basically I'm creating a separate function to make my UI border so better. So draw dot border and the function which creates a rounded rectangle UI. Like using this function, we create this rounded rectangle UI. I'm just talking this. There we have written 17 car. So you can see that this appears in the rounded rectangle form. So using draw dash border function, we create a rounded rectangle UI. Okay, so now further we have the UI dash box. In UI dash box, we just write text over, like you can see that. Okay, so this is a 17 or car, column car. So basically in UI dash box, we basically pass this label value into the rounded rectangle we have created in the draw dash border function. So just this thing, like you can see that we have calling the draw dash border function from above over here and just putting the text over here into it. So, okay. So here we have the function draw dash boxes. Basically here you can see that we are finding the center of the body, bottom edge, and then we are just calculating the identities for each of our detected object. And you can see that we have defining the maximum length of DQ. Our double-ended queue as 64. It will not accept values above 64. And here we are finding the object name. What object name is, like it's car or truck. And here we are just finding the format of our label. Like we have a unique ID for each of the detected object. Like this is here we have, let me show you. Like you can see that 29, 39, 30, each object or detected object has a unique ID, like 29, 39, 36, 38, 30. Okay, so we are assigning a unique ID to each of the detected object, and in the label we have the object name. Well, like if it is car, it is appearing car. If it is motorbike, it is appearing motorbike. And then after finding the bottom center of the bounding box, we are appending this into a double-ended queue. Okay, so basically why we are appending to double-ended queue, because we need to generate trails. Because using this we generate trails. Let me show you what are trails. Okay, this is serious. Okay, so now you can see that this line, just give me a minute. Let me check. So now you can see that this line over here, this line, this is our trails. So basically our each of the center of the bounding box values will be appended into the data DQ, double-ended queue list. And using this, we basically generate a queue. Like you can see that this is the line we have generated. So all because we have appended all the values in the form of data DQ, and using data DQ, we generate this line, like you can see over here. From the bottom center of the bounding box, you can see that this is the bottom center of the bounding box. You can do at the center of the bounding box or the top center of the bounding box. I am just focusing on the bottom center of the bounding box as well. Okay. So here we have done, and here we are just creating, like you can see the trails, like I've shown you the trails over here, which I've shown you, like these are the trails. Like you can see that these are the trails, like this and this. So basically we are creating using CV2 dot line, and you can see that we are taking the last value and the current value to generate the trails. You can see over here in the data DQ. Then we have the data predictor detection prediction function. First, we do the pre-processing. Then we apply non-max regression to resize our upcoming image from the frame by frame. And basically, we have the video in the form of frame by frame to resize that frame. And then further, we are basically doing here annotations. And here, basically, we are performing detections one by one. Like you can see that here, I'm just calling the DeepSORT function, which have I initialized over here. I'm just calling this function over there. Like you can see that this is the DeepSORT function, which I have initialized. So I'm just calling this function over here, DeepSORT.update in the form of here. And basically now I'm just passing these four values. As you can see over here, I'm just passing these four values over here. This is the object ID we are getting as the output. Here we have the object ID as well. Here we have the identities. Like object ID basically help us to find the class name. Object ID basically help us to find. For example, we know that at 0 we have person, at 1 we have car. So basically, if the object ID is 0, we know that this is a person. If object ID is 1, we know that it is a car. And identities help us to assign unique ID to each of the detected object. Okay, and self.model.names basically is help us to get the data, the information from the COCO data set. And this is the bounded boxes. Like For example, from where from the points of the bounding boxes like that, like you can see that. Mm, okay. Basically, this me tells me x1, y1, x2, y2. So this tell me these 2 points of the bounding boxes. Okay. So this gives me the information about these 2 points of the bounding boxes, and this is my current frame, which where I am pending all this information. So this is all the code here. I'm just running the script, and so currently we have run this script till this. So just stop the script and check what out we have. Just stop the script over here. Okay, so let me go to where we have the information. So this is the current output we have. Like you can see that I'm using a nano model, so not giving something very perfect prediction. So like you can see that these are the trails. This is the unique ID and the detection object. Okay, so now moving further as well. Now if you want to implement the number of vehicles entering and leaving, like you can just see at the start of the demo, at the start of the video, so you can run this script as similarly. You can tell me what topics you like. You are facing an issue in such topic. I will create a demo videos for these topics as well. So we are basically creating a complete computer vision series for YOLOv8, and I will be creating 2 to 3 lectures every week. So it's going to be very interesting learning. So do subscribe the channel so that I will share more content. Now let us see what happens. So as the basically, I will explain this file as well. So let us just see. So when this trail intersect this line, let us check it. Player will change when this trail intersect this line. Okay, now yes, okay. When this, like you can see that when this trail intersect this line, it detects like this is the truck one, although it's misdirecting, but it detects that the object has passed. So when this will pass over here, it will do the same. So let us wait for this as well. So just let us wait for a few minutes. It's passing. So, I'm just waiting to just to pass over here. So now you can see that it has passed and it has detected this is a car. So excellent work. So now let me explain you the code, how this process. So the further car, this car will pass, so it will see detect that it will increase the count. Like you can see that now the car has passed, the count has increased to one. Car number one. So now this car will pass, so it will increase the count to two. And if this car will pass, so it will increase the further count to three. So now you can see that this, I just wait for a few more minutes to this pass as well. As it just intersect, okay, the count is increased. So you can just check this out as well. Further, now let me explain this code to you. Basically, in the demo video, you have seen the line at the start, like when the trails of the car intersect with the line, basically it blinks and the count increases. So here we have defined this line. Like, let me show you further so that you don't have any doubts. Let me just give you a minute. So this is the line. Can I edit it? Okay. So this is the line. This is a complete line. You can see that. This is the complete line, green line we are talking. So when this intersect with this line, the count increases. So here I've defined this line as here, and this is the initialization of DeepSORT, and this is all the same code we have discussed, the cardboard border. Let me show you the difference where it comes. This is the same code, and these are the intersect, CCW, and get direction. For example, if the direction is, we have defined the directions. For example, direction is south or north. So for example, and east and west. For we are just focusing on these two directions in this video, like south and north. Okay. So find this function over here. So basically, if the south is in direction, it will increase the count plus one. If not in direction, it will also increase the count plus one. So for example, if the trails are moving in the direction of south, it will increase the count as well. And if the trails are moving in the direction of north, it will increase the count as well. Let me show you. So like you can see that, I just forgot north, south, east, west. South, east, west. This is not this south. Okay, fine. So for example, as you can see that this here we have the south, and here we have the north. So if the trails move in this direction, the count will increase the number of vehicles in entering. And if the trails come in this direction, like you can say, this is in the south direction, it will represent the number of vehicles leaving. Okay. So in this way, we are increasing the count. And here I've just set the UI, like here, just the what is over here is basically I've set all the UI, all this UI. Like you can see that this UI and this UI is being set through this, like this UI. So I have just set the UI and just the same I have run the detector function as well and nothing further. So I hope you have liked this video. So do watch this complete video, and if you have any issues, do let me know in the comment section. I will surely answer.